subdivision or a big mall, okay? And then what happens with that is, in order to provide jobs for all the people who are working in the mall, we have more development. And this is a pretty typical scenario as time goes on, as we get more and more development in your watershed. So what I do next is I give all the kids, so everybody take a house,
Monopoly houses?
take a house, and I let the kids put it in the model. So you get a developer model, take some houses, everybody put them in there.
Right to hotels.
And as long as you don't put it in the river, I have some put it in the river.
In the river?
Jason, you want a
Don't
water?
flood
Not insurable.
Yeah.
Floodway.
Kevin's taking on the
Waterfront
Highlands.
home?
I'm from the Highlands, 2,200 feet.
So anyway, so they'll build their basin.
What is that, Carroll County? You just put that in the
Right.
floodway.
Right. There you go.
Well, he's in charge, you know, you get some benefit out of being in
Right.
charge.
So you let the kids interact, and then so we develop our basin. So the time goes on, things get more development. We got World comes in, provides all these jobs. People move in, they got more development. We didn't have any flooding. And then the question is, we're going to run the exact same experiment with the exact same amount of water. And now the question is, do you think we're going to have flooding this time? And the kids are pretty perceptive. It's like, duh, yeah, we're going to have flooding. But before we move on, I want to introduce the concept of an emergency manager. So then I'll pick a kid out who's not doing anything right now. Who hasn't
Be
been picked?
Jason, the emergency manager.
Jason. Okay, Jason is going to be emergency manager now. So I need an emergency manager because
Can I move that hotel?
if we get into what I want you to do, and I'll talk a little bit about what emergency managers do, but one of the things I want you to do in this experiment is I want you to nab houses that are flooded being washed down the river from going into this tube. Because if they go in the tube, then I got some horrendous backwater, which causes big flooding, and that does occur in real life. So if you miss it, it's no big deal. But what I want you as emergency manager, as we run through this experiment, as you start to see homes float away, then I want you to nab those and just pull them off to the side, just prevent it from going down that tube. So that's going to be your job in this experiment. So you just bring in another kid to do something. So he's watching that. And so, timer, are you ready?
I'm ready.
Reader, what's our first reading? What's our base reading?
5.02.
Okay, so we're starting with 5.02 as our base reading. And timer's ready, and the question is, everybody thinks it's pretty much going to flood. We got an emergency management guy in going here. And things are going to happen pretty fast every 5 seconds, so whenever you're ready to pour, you can.
Okay, read.
5.16.
Oh, no!
Reading.
5.22.
You've already had 2 or 3 drownings.
Reading.
5.24.
Reading.
5.22.
Reading.
5.20.
Reading.
5.16.
Reading.
5.12.
Reading.
5.10.
Reading.
5.08.
Reading.
5.06.
Reading.
5.045.
Did you notice how the water moved off the plane and then kind of oozed its way off of it? Did you see how that kind of worked its way off?
045.
Reading.
5.02.
Okay, we're pretty much done, right? Okay, so we had that experiment. We had major flooding and devastation. We put in the same amount of water, same rainfall event we had, but all of a sudden we had a totally different response. And so what we want to do now is we want to measure how much runoff we had. So the thing to do, what I like to do here for this experiment, to keep things from going crazy, I'll just stick the tube in here. So that's real convenient. So I'll just stick it up in here so it doesn't keep draining. Now we're going to pour that in there, and the kids, we put in 2,200 milliliters. Now we're going to measure how much came out.
Like all of it.
Got 20.
Okay, so hold that up for everybody to see.
Right at 2 liters.
Right, 2 liters. Okay. So the question is, ask the kids, which is good. So they saw we put 2,200, only 2 liters came out. Where's the rest of it?
Depression storage.
Yeah, absolutely.
Exactly. So you got storage, and in some ways you can talk about that's the benefits of a floodplain, because a floodplain will store water. So in this particular case, because of the mock-up, it doesn't store a whole lot, but we've got storage in the channel and elsewhere. So once again, it gives you an opportunity to talk about that. So it's not exactly a 1-for-1, and this will come into play with our next experiment.
There's storage in some of the houses.
Yeah, exactly.
How much
Okay.
was it added? What was it?
2,200.
Yeah, no,
2 liters.
2 liters came out.
Came
Two
out.
2,000
Right.
came out.
So you imagine what your runoff footprint looks like with that experiment compared to the previous experiment. We had 75 versus 2,000. I mean, it's a huge, huge difference. Okay, so what we want to do next is the students, I say, we've got a real problem. How do we solve it? You know, we've got flooding going on down in the floodplain. What are some ways to fix it? And of course, the kids will say, well, move all the houses out. Duh. And you can let that discussion go, and then I'll point out the fact that we can't force people to move their houses out. And the fact that people want to live there, they could dredge the channel. Right. So you kind of lead them through this discussion on ways that we can mitigate the flooding, is what you want to do. You just want to steer them wherever it's going to go. Just get them thinking on, how can we solve this problem? We've got a community that's being flooded, and it's an issue. How do we solve it? And eventually, if they don't come up with it, I'll suggest it, but building a levee. So we'll talk about building a levee. Okay, so when we get